Everyone, I hope you're having an amazing day. Welcome to another episode of 10 p.m. University. So today we're going to talk about integration, right? Integration, let me give you a history about integration before we jump into calculation and integrals and other kind of stuff, right? So the history of integration, you can be predate back to 1800 BC. So probably by ancient Egyptians, right? But the first documented systematic technique capable of determining integrals is a method of exhaustion, right? Of the ancient Greek astronomer back in 370 BC by Exodus. This was applied basically to find areas and volumes by breaking them up into an infinite number of shapes for which area and volumes were known, right? So this method, right, was further developed and employed by Archimedes, right, in 3rd century BC. So what he did, he calculated the area of parabolas and an approximation to the area of circle, right? So that's pretty much around the history. Then Isaac Newton jumped in, then he played a major role in terms of modern calculus, right? Okay, so that's all great. So what does that integration means to, a common man, right? So if you have been watching, so integration is used in deep learning, right? Or it's sometimes in machine learning as well, but it's not very obvious because it's often used by researchers in the white papers. So it's not very obvious when you're working on a, equation or something on machine learning or deep learning side, but it's usually often used by researchers behind the scenes. So, okay, so integration, it's just a reverse of a differentiation, right? So what happened? Let me give you an example, right? If fx, if the derivative of fx is, let's say, right? So the integral of fx of this one, right? So we're gonna do the derivative. If you have attended my previous lecture, you will know that so you can take a derivative of a function and you will get something like this, right? Or you can do d of fx, which are divided by dx, right? So now if you do an integration of this one, right, integral of this, which is represented by this symbol, right? And if you do this, you will pretty much get this, right? Because this is a reverse of differentiation. So in general, what happens is, in theory, so integration of fx dx, right? It often leads to fx plus c, where c is a constant, where it's also called constant of integration, right? And the function fx, right? So this is called integrand, right? So since constant c, right, this one, it can take any value, right? We may get many solutions of a single integrand. So that's why it's known as indefinite integral, right? So you need to know a few properties when it comes to integration. The first one is integration of dx, that will be equal to x plus c, as we have seen here above, right? The second one is that integration of a times dx equals to a integration of dx, is something like that, right? Now then you have integration of dx plus dy plus dz, right? And that something becomes individual integrals, right? So dy plus dz, right? These are very common properties. Just need to keep in mind. So what we're gonna do, just to make it more clear, we're gonna do some some exercise. So that it will come very clear for you what I'm trying to say here, right? So the first one, let me clear this one for you so that we get some space there. I hope it's clear, right? It's the reverse of differentiation when we talk about integration, right? So you take a function fx, right? We have the function here. Let me clear this one. Excuse me. So we have the function here, right? And we take a differentiation of it. We get derivative of this function, and now we take a integration of this one. We'll get fx plus c, which is a constant, right? So let's deal with one example. So let's say you have, okay, before we deal with example, I just wanted to tell you some of the indefinite integration formulas, right? Which is very important. The first one, x to the power n dx, if you integrate it, it will give you result something like x to the power m plus 1 divided by m plus 1 plus c, right? And then we have another one, 1 by x dx, and this will become log of x plus c, right? And then we have another one, e to the power x dx equals to, if you do the integration of this one, will become e to the power x plus c, right? And then we have one more, that is a to the power x dx equals to a to the power x divided by log of a plus c, right? So these are the formulas. It's good to remember. We're gonna talk a little bit about trigonometry as well. As I mentioned, even when I was talking about differentiation, you need to have a bit of understanding of trigonometry, because I won't be covering trigonometry. So I assume that you have some basic knowledge of trigonometry, right? Okay, let me clear this one. And then we do one exercise based on the formulas we've done, right? So that it's become more clear for you. Integration is easy. I mean, if you understand the concept very well, then you can solve complex problems. So today, my main intention is to give you some tools around integration so that you can go and, if you are someone who never did integration before, at least it'll give you an opportunity to go and explore yourself, right? So that's the main thing, to give you integration tool set. So that's my main intention today. Okay, so let's do one example here. Okay, x to the power 6, right, dx, right? So what do you think it should come? Remember the formula we talked about, x to the power n times dx equals to x to the power n plus 1 divided by n plus 1 with plus c, right? So using that logic here, x to the power n plus 1. So here n is 6. So n plus 1, 6 plus 1, right, divided by n plus 1. That is 6 plus 1. And plus c. C is a constant, right? So that will be x to the power 7 times 7 plus 1. Okay, c. Okay, let's do another problem. X to the power 2 by 3 dx, right? So as usual, if you remember that we are actually talking here n equals to 2 by 3, right? So we can write this something like x to the power 2 by 3 plus 1 divided by 2 by 3 plus 1 plus c. That will equals to something like 3 x to the power 5 by 3 divided by 5 plus c, right? Sounds straightforward, right? Okay, cool. Let's do more example so that it becomes clear. So this is an example, very straightforward integration, right? So let's do when we have multiple, like sum of integrands. So I'll show you what I meant by that. Let me clear this one. So, all right, it won't take longer. Just a second. Right. I mean, mathematics is fun. I mean, if you ask me, if you ask my opinion, it's not difficult, right? It's just that some people think, oh, too much of complications, oh, it's difficult. It's not the case. I mean, if you really think about it, if you start working on stuff, then you really started to enjoy it. It's not bad, to be honest. Okay, so let's do another example here. Okay, so we have something like integration of 3x squared plus 2x plus 1 dx. So if you remember, we talked about a property where we split this into three parts, right? So something like that. So you can write it as three. So you can write it at 3x squared dx plus 2x dx, right? Plus, right, dx, right? Something like that, right? And this you can split into 3 of x squared dx plus 2 of x dx. Now, this one you can also write as x to the power 0, which is 1, right? 1, x to the power 1 is 1, so I substituted 1 with x to the power 0, okay? Right, now, so we're gonna get something like this, 3, and you do the integration of this one, so x to the power, so this is n, right? So what is n plus 1? That is 2 plus 1 divided by 2 plus 1, right? Plus 2, and so x, what is n is 1, so 1 plus 1 divided by 1 plus 1, right? Plus, and here you have x 0 plus 1, right? And 0 plus 1 plus c. So this will become something like 3 x to the power 3 by 3 plus 2 x to the power 2 divided by 2 plus x plus c, right? Sounds straightforward? So let me walk you through the problem again. So we have to find the integration of this equation, right? So we split it into three parts. So, you know, based on the properties we have. So we split them into individual 3x squared dx plus 2x dx plus dx, right? Now, this can be written as something like that, right? As because 3 out, and then we wrote something like that, and we did something like that for this, and for just to make it consistent, because we have x everywhere, right? And so 1 can be substituted with x to the power 0, right? That's pretty straightforward, because x to the power 0 equals to 1, right? Or even you can put xy to the power 0, but we are dealing with x here, so that's the reason why, you know, I made it x, right? If you were dealing with y, we could have dealt with y, right? Okay, so now we're gonna do the integration of this one, right? As you remember the property, what we have, the formula, x to the power n, that's equal to x to the power n plus 1. Here n is 2, right? N plus 1 divided by n plus 1, that is 2 plus 1. Plus, right? So you're gonna take the integration of this one, so x to the power 1, right? So n is equals to 1 here, so we're gonna do n plus 1, so that's 1 plus 1 divided by 1 plus 1, right? And now here, the same formula we're going to apply. So x to the power n, right? So what is n here? N is 0. So x to the power n plus 1, that is 0 plus 1. And divided by n plus 1, that is 0 plus 1. That equals to, will lead you to this, right? That's all. Pretty straightforward. Okay, let me clear this. Then we're going to do a little bit more complex example, right? We're going to do with the log. Okay, just a second. So you know what I'm gonna do? I'm gonna split this lecture into two parts, right? I'm gonna do part 1, where we're gonna do more exercise, and we're gonna do definite integrals in the next time, right? Because I don't think so we're gonna have time. So if you're gonna do a lot of exercise, because I wanted to do a lot of exercise so that you guys can understand what I'm trying to say, right? There's no point for me to rush into stuff, and you know, then you guys get confused and wonder what the heck this guy's talking about, right? So I just wanted to make mathematics simple and enjoyable at the same time. I know that right now you guys might be thinking, oh, this sucks. I understand that integration is not so easy, but stay with me. It will get more clear when you are dealing with examples, okay? All right, so we're gonna deal with another property now. Okay, let me see this one. Okay, so I'm gonna write the properties at the top here. All right, so if you remember the property we dealt with, this is one of the formulas we have, dx equals to log of x plus c, right? Cool. And then we have another one, so ax dx excuse me, a to the power x by log of a plus c, so that you remember, right? So we're gonna start from here to start the equation, right? Okay, so the equation is something like this. Integration of, okay, a to the power x plus b to the power x plus c dx, right? This can be written as something like that. Sorry, a to the power x squared, right? And b to the power x plus c. This is x. Sorry for my bad handwriting. So you can write something like this as a to the power x minus 2, right? Plus b to the power x minus 1, right? Because x minus 1 is obviously 1 by x plus c, right? And dx, right? And this can be written as, okay, let's do, so a to the power x minus 2, that will be what? So here, the same formula applies, x to the power n. N is minus 2. Minus 2 plus 1, right? And minus 2 plus 1, right? Okay, now plus, pay attention here. It won't be x to the power n logic here. We're gonna use an equation here. So you remember this one? 1 to the power dx, it will be log x. So we're gonna substitute this as log of x, right? Because remember this one? Forget about c for now, right? C is a constant, so we don't have to worry about it. So I'll take this off for now, right? So 1 of x, integration of 1 of x dx equals to log of x. So exactly what we did, right? So b times, so you can do this something like that. You can take the b out, and it will be integration of 1 over x times dx, right? If you remember in my previous exercise, I've showed you how to split this into 3 integrals, right? So we can do integration of a x to the power minus 2 dx plus integration of b x to the power minus 1 dx plus cx, right? So, okay, now here, c, right? So remember what we talked about c, right? So c, you can write it as x to the power 0, right? Remember from the previous exercise we did? Because we are replacing 1 with an x for consistency, because we have x here. So here, n is 0 plus 1, right? 0 plus 1, right? Plus c. So this will be something like that. It'd be something, what, minus... so it will be something like that. A x to the power minus 1, right? Plus b log of x plus cx plus c, right? So this is the answer you get. So pretty straightforward, right? And so this is how you do very basic stuff on integration, right? So what we're gonna do, we're gonna jump into a little bit more complicated example so that you can become clear. Then after that, I'm going to show you some of the integration of trigonometric functions. So one more example, then we go to integration of trigonometric function. Then after that, what we're going to do, indefinite integration by substitution, right? So that's one of the things I want to cover. After that, we're done, right? I promise I won't keep you longer. Right, so we're going to do this, clear this one. That's why I said we're going to split into 2 parts, and so that we're going to talk about definite integration next time. Otherwise, you're going to take ages to explain each and every stuff, right? Because integration is a little bit harder compared to differentiation, so that's why I'm, enforcing more time on showing you guys different exercise. Okay, so one more exercise. Then we're going to talk about a little bit of trigonometric functions, so then we're going to deal with it. We're done with it. So, okay, so this one. Sorry about that if you're hearing that cop siren. Strange thing happens at times. I live in a quiet neighborhood though, so we don't have much crime. I mean, I live in a small town in New Zealand, so you can expect. We're not in a big cities like where a lot of things go down. Okay, so if you remember in your algebra class, a plus a plus b whole square equation, right? A squared plus b squared equals to 2 times a times b, right? So the same concept applies here, right? So all right, so this is a plus b the whole square equals to a squared plus b squared plus 2 times a times b, right? So we're gonna use the same thing here. So we're gonna do x to the power 4 plus and 16x squared plus 64, right? Okay, dx. All right, now use the integration here. Pretty straightforward. Split into 2 parts, right? x4 dx plus 3 parts, in fact, sorry. 16x squared dx plus 64 dx, right? This will become what? X to the power n, right? So let me clear. Right. So this will become x to the power n. So that will become x to the power 4 plus 1 times 5 plus, and this one. What do you think? It will become 16 x to the power 3 plus 3 plus 64 x plus c. There you are. This equals to x to the power 5 by 5 plus 16 x to the power 3 by 3 plus 64 plus x plus c, right? Pretty straightforward. You know, by now you guys should be knowing how to do this because I've covered many examples already. Okay, so we're done with this one. Now let me show you some trigonometric formulas, and after that we're gonna get into substitution part of it. So we're not going to do any graphs or stuff. Probably we're going to do next time. Right. So right. Just bear with me. Just cleaning is a nightmare. Right. Okay. All right. That's right. I like this cleaning part. It reminds me of my high school time, right? When my professor used to clean, because we used to, have the board and the chalk. So I hope some of you can relate. Today's time, it's all about markers and other stuff, right? Okay, all right, cool. So what we're going to do, we're going to talk about integration of trigonometric functions, right? So we have something called sine of x dx, right? This equals to minus cos of x plus c, right? Now we have cos of x dx equals to sine of x plus c, okay? Now secant square x dx equals to tan of x plus c. These are the formulas. I mean, you can Google it. I mean, just to tell you for your own information. I had trouble remembering it. Sorry, my apologies. Okay, and then we have a so for now that's good for now, right? Okay, so I think we do one. Let's do one example with trigonometry. Okay, so we do a very simple one, right? I don't want it to confuse you guys, so you can research by your own. Right, now since you have the tool, the formula tool, right, so you can figure out by yourself. You can practice. If you're someone who's interested, you should practice mathematics. You can't do mathematics just by looking at someone else doing it, right? You need to do it by yourself. So that's how you learn stuff. Okay, so now, all right, integration as usual. Dx plus sine of x dx plus cos of x dx, okay? Right, now, what is the dx? If you remember from a previous exercise, it's 1 times dx. Replace the 1 with x, right? X to the power 0, so it will become x, okay? Now, integration of sine x dx, as you know from here, okay? Forget about the c for now, right? Okay, so you have cos of x, okay? What is the integration of the cos of x? That's become sine of x, okay? And at the end, you'll put c, right? That's pretty much it is. Pretty straightforward. So if you know the formulas, you can solve the problem It's that simple, right? Maths is all about it. If you understand the equation very well, you can solve, the complex thing. Okay, all right, cool. Now, okay, you know what? Let's do one more. So that just to give you one more example. Okay, so one more. I promise won't be more. Then we're gonna get into my substitution problem. Okay, just a second. It's nice and easy. All right. Yeah, that's the fun with the maths. When you start doing it, you get carried away. Or say, oh, I can do it. Sometimes you spend times and ages. Okay, cool. Anyways, never mind. All right. So let's take one more equation. So integration equation. So, 3 sine of x minus 2. Okay. All right. Now, how do you solve this one? Okay, it's pretty straightforward. Let's split it into 3 parts. 2 parts. All right, minus 2. Right? Okay. Now, right? Okay, now it's pretty straightforward. This one from here, sine of integration of sine x dx, right? It's minus cos x. So 3 times minus cos x minus, and this one, integration of this one, it will become tan x, right? Minus 2 tan x plus c. So this is equal to minus 3 cos x minus 2 tan x, okay, plus c. Sounds easy, right? Nice and easy. Cool. Right. Okay, no more exercise. Now, let's get into our substitution part. Okay, let me clear this. Oh, I love the clearing part of this. That's fun. All right. Yeah. All right. Just more, a little bit more, a little bit more, a little bit more. Yeah, okay, a little bit more, a little bit more. It's get fun. This is the best part. Right? I mean, I enjoy doing this one the more than writing it. I mean, I wish my stylus can write by itself when I talk. We don't have that technology yet, maybe. Probably in 5 to 6 years we might. Cool. All right. Okay. So what we're going to do, we're going to talk about indefinite integration by substitution, right? So I have to show you this big example. Otherwise, it's a bit tricky, right? So let's assume I have to show this by example. I can't do this by equation to get more confusion. So, okay, let's evaluate, right, this one. A x plus b n dx, right? So this is where this is indefinite integration, because definite means you will have value here from 0 to 1 to 2, right? This will become definite, but we are not doing that for now. Don't want to confuse you guys. So we're gonna do with indefinite, right? So we have to solve this equation. Now, how do you solve it? We can't do that x to the power n plus 1 by that gets a bit tricky, because it's not as because we can't use that equation, right? So what we have to do, we're gonna use the substitution principle. So what we're gonna do, we're gonna substitute this ax minus b, right? This one, let's put it as t, okay? And now we're gonna differentiate it with respect to t. So what's gonna happen when you differentiate this with respect to t? So you're gonna get something like a dx by dt, right, equals to 1, right? You could do differentiation of both sides, right? And now this will becomes what? So then we have dx equals to dt by a, right? Because you move the t to here and a goes down, right? So this will become the equation. So what happens here? So this will implies something like this: t to the power n, because we have substituted this with t, remember here, right? And now times, now dx values here, right? So dt by a, come on. Sorry, not dt by a. Okay, just dt, yeah, sorry, dt by a, okay? Now, that's fine. Okay, now we're gonna do, let's use the same equation we used before. You remember when I talked about x to the power n? So we have something called x to the power. Now we are actually doing differentiation with respect to t, integration with respect to t here, right? So we use the same formula, x to the power, so x to the power n equals to x to the power n plus 1 divided by n plus 1. So similarly, we're going to use this one as t to the power, n plus 1 by n plus 1, right? Okay. Times a plus c, right? Because you remember just now we talked about the formulas, x to the power n, so exactly what I did, plus c, and a is there, right? So now what we're going to do, we're going to replace the t back with this one. So we're going to do 1 to the power a, 1 by a, so we're going to go ax plus, ax minus b. Sorry, what we're going to do, sorry, it's going to be t plus 1, right? Right, okay, so we're going to do plus 1, right? Just to simplify it. Because I always like to start everything with plus, negative, we're going to deal with that. I'm not superstitious, but just for the, yeah, I find it more comfortable, so. Okay, so what I've done, so I substituted the value of t with this one, right here. So that's exactly what I did. And so this is the answer. So this is our substitution. Right, if you find it confusing, don't worry, we're going to do more exercise now. Let me clear this one first. Right, and we're going to, I know the substitution can be tricky at times. That's why I said integration at times can be challenging, but if you understand the concepts of fundamentals, you will find your journey with integration much easier, right? So don't get overwhelmed. Stay with me. I know that you must be thinking, maths, right? Yeah, I know. I get that feeling. When I was in high school, I used to think that as well. But you know, as I got older, I realized that mathematics plays a very important role because we are part of this universe, right? The language of universe. You can, you know, if you have to interact with an alien race, you obviously have to use mathematics. You can't use any language. Our English or French or Japanese, they won't understand anything. They were like, what the heck this guy talking about, right? Mathematics is the only language which you probably can use across the, in our solar system, hopefully. Right, rest of the languages are for human beings, right? For us, for biological models like us. So, okay, all right. Okay, now let's do another one. Okay, so this one will become more simple. 3x plus 5. Oh, come on. Okay. Right. Right. Now, we're going to use our substitution rule. Okay. So we're going to do t equals to 3x plus 5. Right? Okay. Use the differentiation. Both sides. This will become what? dt. Right? Equals to 3 dx, right? Obviously, because you're going to have to do differentiation, right, with respect to t on both sides, so this is what we get. So because differentiation of this one will become 1, and this will, you can put, t times 0, so that will actually become 0, and this will become 3 times, so 3 by 3 dx by dt, right? So you move the dt to that side, so, and this will equals to something like dx, sorry, so 3 equals to dt by, sorry, come on, dx equal to dt by 3, so right, something like that. Okay, now what we're gonna do, so we're gonna do something equals to 3x plus 5, 6, So dx equals to dt by 3, right? And then you substitute this equal to t to the power 6 times dt by 3, right? Now use the same integration principles what I've taught you until now. So x to the power n, right? So that's exactly become, just put it here, right? And you're gonna do t to the power 7 times 7, right? And plus c, right? So this will become t to the power 7 times 21 plus c. Now substitute the value of t back. So 3x plus 5 to the power 7 times 21 plus c, right? Sounds simple, right? Very, very easy. Cool. So this is how you normally perform integration by substitution, right? So I think I've given you enough information about the different formulas you can use in integration, basic integration to indefinite integration by substitution, right? We haven't talked about definite integration, so that's we're going to talk about in our next lecture, right? So I don't want to overwhelm you guys, so that's why I kept it very simple, right? And we have covered enough examples. So if you have any questions, please always ask the question in the comment. If you think there's something I haven't covered, so please let me know it as well. I try to cover that in the next lecture, right? So I have given you now integration tool. You have a powerful tool in your hand. Use it wisely. Research more about it. See what you can do with it. See what you can play with it. See you can come up with something with it, right? Mathematics is a magical thing, so you have great power in your hands. So it's up to you to see what you can do with it, right? Cool. That being said, that's all I wanted to cover today. Thank you very much for your time today. Greetings and adios from New Zealand. Bye-bye.